Hello everyone, welcome to your last session of this revision course. So today's once again going to be an hour. It will be recorded and sent to your parents, and yep, so this is the last one. And we're going to just do a recap from everything we've learned in the past 4 days, all those topics. There's going to be 3 Kahoots to look forward to, and then we're also going to cover exam techniques, and we're just going to finish with a couple of past papers to go through. Okay, so let's start with the recap. Exam techniques and recap. So firstly, what did we cover in lesson 1 back to Monday? We learned that the nucleus has both protons and neutrons. They're found in the nucleus. Protons, they have a positive charge, and electrons have a negative charge. So we know that on here, our proton number, it tells us the number of protons that we have in our atom. And we have learned that our protons are equal to the number of electrons. Yeah, so remember that the proton number, also sometimes called the atomic number, is the number of protons in the atom, and this is equal to the number of electrons in the atom. We need to also know that the mass number, so this number at the top, the relative atomic mass, that is the number of protons and neutrons in the atom. So these are your key takeaways from lesson 1. And there's a few more. So let's quickly run through an example. If we take boron, the atomic number at the bottom, also known as proton number, is 5. So then how many electrons is it going to have? It's going to have 5 electrons too. And how many neutrons is it going to have? So 11 is our mass number. That's the number of protons and the number of neutrons. So 11 take away 5 gives us the 6 neutrons present in our nucleus. Okay. So another thing to note with this part, because protons have a positive charge, that means, and electrons have a negative charge, they're equal, and so the atom is neutral. So protons equals electrons, and that's why your atoms are neutral. Okay, so what did we learn about chemical equations? We know that a chemical equation, it shows how the reactants go to form products. So if we say have our water equation, H2 plus O2 goes to form our product of water, so H2O. Obviously, so yeah, so these are our reactants, these are our products, left-hand side for reactants, right-hand side for products. The chemical reaction, we now know, must be balanced. What's that mean? It means that we have the same number of atoms on the left and on the right. So therefore, we're going to have to balance this. Although we've got 2 hydrogens on the left and the right, we also have 2 oxygens on the left, however, just 1 on the right. So we're going to have to make the right to 2 oxygens, which puts 4 hydrogens, and so therefore we need to make 4 hydrogens on the left. Yeah, so we balance equations always by putting a big number in front of the compound or the elements. So in this case, if we had this one, some of you may be tempted to balance it by adding a little 2 here, but this is incorrect because you never balance it by adding a small number. The number must always go in front of the compound or the element. So it must go here and it must go here. You can't change this to say 4 for it to be balanced, okay? The key things to note. If people have any questions, please put them in the question box, and if you guys want to answer any questions, put them in the chat box, please. So compounds versus mixtures. Firstly, let's just talk about what an element was. So an element is a substance that's made up of just one type of atom. So if we say had oxygen, O2, although we've got 2 oxygen atoms in our molecule, it is not a compound because it's just one type of atom. It's just one type of atom, which is oxygen. And say, for example, fluorine as well, F2. It's a molecule, but it's just got one type of atom, which is the Fs. What about a compound? So that means there are different atoms chemically bond together. So what's an example of a compound? Water, say, is H2O. It's got a hydrogen and an oxygen, and they're chemically bonded together, just like NaCl. It's chemically bonded together. Brilliant, or CO2, as someone has said. So if you had Na by itself, now that is an element because it's just got one type of atom. But if you go to NaCl, it is now a compound because it has two different types of atoms. Dun, dun, dun. So if you put a big number, let me just quickly read the chat. If you put a big number in front of a substance, does it mean there are two oxygen molecules? Yeah, exactly, brilliant. So when you balance it, well done. So you've got two of these, say oxygen, it has a double bond. Yeah. So therefore, if you put a 2 in front of the O2, it means there are two oxygens, like so. Perfect. What is a molecule? A molecule is a compound that has covalent bonds. Yeah, brilliant. NaCl would be an ionic compound. Sorry, so I just wanted to ask, if I get a tutor on this, will they teach all GCSE science, or do I have to get? So there are some tutors who do teach all 3 sciences. There's some who just teach 1 or 2. Really commonly, say, like tutors, they would have taken chemistry and biology, or chemistry and physics. So I'm not so I think there is tutors that do tutor all 3 sciences, yeah. But commonly, which way do you write it in the exam? Which way do you write what? Sorry. What's the difference between an atom or an element? So an atom is always on itself. So like O as an atom is just that, whatever you see in the periodic table. But in its element state, it always comes as O2. So what we need to remember is that O2 is an element, although it is this molecule, because it's made up of just one type of atoms. Atoms are just what's written in the periodic table. So these are all atoms. But your element, say your element, these are all atoms that come as F2, Cl2. These are your elements. Okay. The compound. Sorry, I don't know what's drawn about the compound. Is it possible to have a group 5 atom react with a group 7 atom? Yeah, definitely. It's group 5. Yeah, you do have those reactions, but they're not GCSE reactions that you'd need to know. So Na is an element. Yeah, okay. It's really good input in the chat. Dun, dun, dun. Okay, so let's move on to the next bit. So compounds, sorry. So compound are different chemically bonded, different atoms chemically bond together, like these ones. So this is a covalent compound. This is an ionic compound. Covalent compounds, they have covalent bonds, obviously, and ionic compounds have ionic bonds, which hopefully some of you have covered at school, but we won't be covering that. So a mixture. A mixture is different substances that are not chemically bond together. This is the key bit to note with here. Okay. So, next page. Can we remember the different physical separation methods? So we've got our filtration, our crystallization, our distillation. So we put A, B, C. Which one's the filtration then? You want to put that in? Yeah, brilliant. Which one's distillation? Yeah, great. And crystallization is B. Brilliant. Well done, everyone. So how does filtration work, and when do we use filtration? We use it when we need to separate insoluble compounds or substances from a liquid. We just run it through our filter, through our funnel, sorry. We need to remember we need to have this filter paper. That's what catches the solid, and the rest of the liquid, it just runs through. This is called the filtrate. This is called the residue. Some names that you might need to know. Okay, how does crystallization work? So here we've usually got something dissolved in it, like say salt or sugar, which are solid without water. We evaporate the water off and just leave the solid as it's removed the water. Distillation, so that's if say we want to separate the salt solution and keep our water at the end. We know we evaporate it and then we condense it through this condenser because it's always cool. And then we have our water at the end that runs through. Okay, that's a little quick run through of those ones. Yeah, brilliant. So next one. So what do we do in lesson 2? We had some more separating methods, didn't we? So we looked at fraction distillation, which we used to separate miscible liquids. What was a miscible liquid? It's a liquid that fully dissolves in another liquid. So are water and oil miscible? No, because we always see this line, don't we? And then, so we always see our two things. So yeah, we need two miscible liquids. Can people give me an example of miscible liquids that we've come across a few times now? Can you have any examples? Okay, so that oil and water is not miscible. Say ethanol and, so ethanol and water, brilliant. Everyone who's saying ethanol and water, that's really commonly. So we'll explain the physical separation methods again at the end if we've got time. Brilliant, okay. So how does it work? The top of the fractionating column was cooler than the bottom. The fractions with high boiling points condense at the bottom of the column where it's warmer, and those with lower boiling points, they go to the top and condense there. So we use paper chromatography to separate substances with different solubility in the solvent used. Okay, so quick run through. This is our fractionating column. The bottom is really warm, the top is much cooler. Those with a high melting point, they condense here and drop back in here. Those with a low melting point, they reach the top and go to the condenser, and that's why you collect it here. So what temps are the top and the bottom? You don't need to know that. You just need to know that the top is much cooler than the bottom. So in this case, yeah, just need to do that, because and the thing that has the lower melting point is going to go into the condenser. So in this case, ethanol has a lower boiling point of 78 degrees. Water has a boiling point of 100 degrees. So the ethanol, it goes to the top and condenses, but the water just drops back down, and you have separated it. Okay. And then paper chromatography, you draw on your line with, what was it? We can't draw it on with pen, we must draw it on with pencil. Brilliant, because you don't want it to dissolve in the water. You dot on your substances that you're investigating and you put it in the solvent. We must make sure that the solvent is below our pencil line, and the solvent travels up the paper and carries the substance with it. Okay. Dun, dun, dun. Okay, so this is, so we did also a bit of electronic structure back on the second lesson. We learned that the first shell holds up to 2 electrons. The second and the third hold up to 8 electrons. Most stable configuration is a full outer shell. So that means if you've only got, if the outer shell is the first shell, it only needs 2 electrons in its outer shell for it to be stable. And if it's the second and the third one, it needs to have 8 electrons for it to be happy and stable. Yeah, so all atoms want to reach the stable configuration. Noble gases, they're already in this stable configuration, and that's why they don't react. They're so unreactive. What about the fourth onwards? You do not need to know this. This will be made clear when you reach A levels, if you guys are interested in taking chemistry A level. Okay, let me quickly look at the question answers. How do some elements have 8 electrons in some shells? You don't need to know stuff like that. Okay, I've actually got 2 Kahoots on why does the solvent have to be below the pencil line? Great question. So where is it? The way that that paper chromatography works is that the water, it travels up the paper and dissolves this thing in it as it moves up the paper, right? And carries it up. If, say, your water was at the top here, it's already in the water, so the water starts traveling from above the dot. So therefore, it's not going to carry it up well. Does that make sense? I don't think you'll ever be asked to explain why it has to be below the pencil line, but it's just because it won't be carried if it's below the pencil line, if it's above the pencil line. Okay. Do you have to take chem and bio for medicine? I think so. I don't do medicine, but yeah, I think from most universities you do. Are the alkanes miscible? Yeah, they're miscible with each other. What are alkanes? They're hydrocarbons. This is like quite a lot later on in this chemistry course. Is there a method to find out the electron capacity in a shell? All you need to know is the first one, it can only take up 2. The second and third ones, they can take up to 3. Why does the color change in chromatography? I think you mean why is there like yellow and red? Is that the color change you're referring to, say, for the orange example? Yeah, so what you're doing with paper chromatography is that you're separating, right? What this shows us is that the orange color is made of a substance that has a yellow color and a substance that has a red color. So that's why the color changes, because you get to see what colors are making up this orange. So it's not the colors changed, it's that the color has been separated into its 2 like primary colors, say. If the ink is insoluble, will it stay on the line? Yep, it's not going to move because it can't move upwards. Okay, so should we try the Kahoot then? Are there any more questions for lesson 1 and 2? What's the difference between evaporation and crystallization? So evaporation is used in crystallization. So at the end, what you're doing is you're crystallizing your solute. So obviously, you know what sugar looks like. That's a crystal structure. So sugar is a crystal. So when you dissolve sugar in water, to separate it, you evaporate the water first, and then you reform these crystals, reform these sugar crystals, and that's why it's called crystallization. So evaporation is it evaporating the water. Crystallization is it forming the solids. Are there other versions of chromatography like distillation? No, there isn't. Nothing you need to do. We'll talk through the physical separation methods at the end if we have time, because there's actually quite a lot to cover in this lesson. That's okay. How long is the Kahoot? So there's 3. They're not too long, but we'll do 2 now. Okay, let's go. So lesson 1 recap. This was only 5 questions. The other ones. 25. So if people can't join, please write down your answers and you'll see them at the end. You can check it. Is chromatography another separating method? Yeah, it is, but it's not like the other one. So it's like more, yeah, please join, the code is up there. It's more used to say, see like what colors make up an ink or what substances are in something. It's not really used to say like we separate sand from water. We can actually have them physically, like we have them. It's more to just see what substances are in another. Are there other versions of chromatography? No. You said that one. Dun, dun, dun. Okay, brilliant. We'll give it half a minute or so to let everyone get on. Okay, once this number stops changing. Okay, we'll start in 10 seconds. 10 seconds. Yeah, I think we're ready. So let's press start. So first lesson recap. Let's balance this equation then. Oh, this might be a bit fast actually. Yeah, I think it's slightly too fast, this one. Dun, dun, dun. Well done to everyone who pressed it right. Sadly, I don't think I gave you guys enough time to actually fully balance it and count up the atoms, but I'll go through it after we're done with this thingy. Well done to Sal for coming first. Okay, next one, question 2. How many protons and neutrons are in molybdenum? Yeah, well done. Lots of correct answers. So we'll do this one afterwards. So we'll go through everything at the end. Well done, Sophia, for coming up to the top. Which of these is not a mixture? Yeah, well done. Good. Yellow, because sodium chloride is what? An ionic compound. Exactly. We'll talk through why it's not air after this. So, fourth question. The characteristic of a compound is... Oh, that's a question. Yeah, well done. Whoever answered it is correct. Sophia's keeping her place at the top. Well done. So which is an example of just compounds? Which of these have just compounds in the answers? Well done. Great effort. So that's the end. Let's see who came first. Well done to you all. And well done to Sophia for coming first. Well done. Okay. Dun, dun, dun. Yeah, everyone found this one difficult, but I think that was because there was enough time. So the answer was this one, because if we count up the aluminiums on the right, we start with 2. So then we know that we have to put a 2 on the left because we only have 1 on the left. How many oxygens and hydrogens do we have on the left? If we put a 2 in front of that, we're going to have, so this little one tells us there's 3 oxygens and 3 hydrogens. So therefore 2 times 3 is 6 oxygens on the left. However, now we've still got 4 oxygens on the right. So if we put a 3 in front of the H2O, then we're going to get to 6 hydrogens and 6 oxygens in total. I go through it more on the whiteboard if we when we do that, but I'll go through them. Dun, dun, dun. Next one. Yeah, well, let's just close it out. Let me just take it out. So yeah, how many protons and neutrons were in molybdenum? So we can see here 96 is our mass number, 42 is our proton number. So therefore we're going to have 42 protons and we're going to have 54 neutrons, because 96 take away 42 is 54. So which was not a mixture? It was sodium chloride, because that's the only one that is a compound. Otherwise, sand and water is a mixture because they're not chemically bonded. Salt and water is also a mixture because, once again, they're not chemically bonded. And then air is a mixture because it's made up of oxygen, nitrogen, a bit of CO2. So it's just lots of different gases that are mixed together. So then characteristics of a compound, well done, lots of people got it correct. Fixed composition. It can't be separated by filtration because that's a physical method and we need to separate it through chemical reactions, and there are no chemical bonds between substances. And which is a compound? So only the blue is are compounds because the rest all have elements. So in that case, they're all elements. This one, F2 and O2 is an element, and here O2 is an element. Okay. A fixed composition is so if say we had NaCl, you're always going to have one Na to one Cl. So that's a fixed composition. However, if say we had sand, and if say this is sand and this is say water, that's like a half sand to a half water, say, then we could have like this much water instead. So you can just change the composition ratios. Mixture and compound difference. So compounds are chemically bonded, mixtures are not chemically bonded. That's the difference. Okay, so let's do the other Kahoot then. that was on lesson 2. Then we'll move on. Okay, so if people want to connect again. Dun, dun, dun. So you'll have a minute or so to connect to this one. You will never need to learn the lanthanides or the actinides. They're actually covered. I did them last year in chemistry in the university. So 3rd year of chemistry, we actually learned about them. You don't do them in A level, you don't do them in GCSEs. Okay, we'll give it 10 seconds and then we're going to start. Please put any questions that you're having in the chats. Okay, we're going to. So what grade did I get for A level and GCSE? I got A stars in both of those. No, it's not. After this one, we're going to cover more content. Okay, we're going to start. So in fraction distillation, the top of the fractionating column is how do I revise? I'm going to go through that soon after these. What careers are there if you do chemistry? There's lots of careers. Currently, I'm looking at jobs. There, you can do anything after chemistry degree, really. Okay, brilliant. Well done to everyone. Cooler. So yeah, the top is cooler, the bottom is hotter. Well done to great teacher. Paper chromatography separates substances because they have a different solubility, they have a different melting point, or they have different colors. Okay, well done. Yeah, so it's not that they have different melting points, because that's not how we separate them, and it's not that they have different colors. Obviously, when we're separating inks, a lot of the substances do have different colors because they mix to make the final color. But yeah, it's to do with the solubility of the solvent that you're using. That's what determines it. Okay, well done to Mimi coming up. How many different substances are present in this molecule, in this substance, sorry? No, we're not doing the Kahoot for the whole lesson. Okay, 3, well done, yeah. So it's because there was 3 dots on the paper above the dot on the line. But there are 4 dots. Yeah, there were 4 dots, but one of the dots was on the paper, and that's the dot that is being separated. Okay, I'll show you that at the end. Well done. Yep. So how many electrons they have in the outer shell? They're in the groups. Obviously, the group number tells us how many electrons are there in the outer shell. So we just need to have 3, 4, and 6. Well done to Mimi for keeping her top place. And last question: what's the electronic structure of P? It's going to be on more some past paper like questions, which take a bit longer. Okay, brilliant, well done. Most of you guys got that right. So yeah, 2 in the first shell, 8 in the next shell, so that adds up to 10. So 5 in the last shell. Perfect. Okay, that one done too. Well done to Mimi for coming 3rd. And first is Michelle, well done. Okay. So we quickly look at this one. I don't know if it'll let me. Let's look at this one quickly. So yeah, so some of you guys may have seen 4 dots. This dot at the bottom, it does not, on the line, that is not counted as one of the substances. So this is the substance that's being separated. So if you need to figure out how many substances are in this thing, you need to count the 3 that are above the line, okay? You need to count however many dots you see above the line that you've put the thing on, okay? Hopefully that makes sense. Dun, dun, dun. Okay, so let's do quick recap of lesson 3. So that was group 1 and 7. The key notes was that group 1, the reactivity increased down the group. Group 7, reactivity decreased down the group. So the reaction with water and oxygen. With water, what did we form? We formed oh, so if the dot's further up the paper, it is more soluble in the solvent. Good question. Sorry, I'm looking at the questions before we move on to this thing. Yeah, brilliant. So some of you guys are answering. So yeah, let's take Na, for example. With water, it's going to form plus H2O, it's going to form sodium hydroxide and hydrogen. Brilliant. So what's going to happen with oxygen? Sorry, it's not a balanced equation. So if we react with oxygen, what are our products? The product is just sodium oxide, okay? So these are the 2 things that you need to remember and then be able to apply. No, you can't test all groups' reactivity with displacement, only some. Only some you need to know. Okay, so group 7 and has 7 outer electrons, wants to gain an electron. Group 1 wants to lose an electron. You can tell, sorry, halogen reactivity using displacement reactions. Okay, factors determining how easy it is to lose an electron. I hope you remember it from the other day. The size of the atom, the larger the atom, the further away the outer electron is from the nucleus. So it's easier to lose it because there's less attraction between the nucleus and the electron. Also shielding, or you can say also the number of shells between the nucleus and the outer electron. So the more shells there are, the easier it is to lose this electron because there are weaker attraction, less electrostatic attraction between the nucleus and the outer shell. Okay. So let's quickly recap lesson 4 then. Yes, dun, dun, dun. What do you mean by the size of the atom? So say if we had like, let's go back to our periodic table. So say if we're going to look at oxygen, this atom is going to be a lot smaller than our sulfur atom. Okay, so when you've got a larger atom, your electron is much further from the nucleus than say if you had a smaller atom. Yeah, if the nucleus is say here, our electron is much further in this case than it is in this case, so there's a weaker attraction. Okay, so lesson 4. So yesterday we did some work on transition metals. We learned that the transition metals were non-reactive, they are hard and they are dense. And they obviously sink in water then. They're found between group 2 and 3, so they're that big square block. You might be able to see in the periodic table, the blue part of that one. They can form different ions. So like we learned about copper, it can form 2 different ions, which were copper plus and copper 2 plus. They also formed colored compounds, which is not, so alkali metals, they form not colored compounds. And they're used to form catalysts. So yeah, so that's just a brief summary on transition metals. And hopefully some of you remember we did isotopes yesterday. Do we need to know the different ions transition metals form? No, you just need to know that they do form different ions. That's all you need to know in that. So what were isotopes? It is the same element. So they have the same proton number, but different number of neutrons. So the atomic number always stays the same, it never changes, but the mass number, which is both protons and neutrons together, does change. And that's the difference. So isotopes, they have different number of neutrons. So chemical reactions, the chemical reactions of these isotopes, they are the same because it's determined by their electronic structure. And obviously, because we know that the proton number stays the same, which is equal to the electrons, therefore they have the same electronic structure and same chemical reactions. Okay, hopefully that made sense. Quick. Yeah, so it's really common in the exam that they ask about the difference between transition metals and alkali. I've been looking through some past paper questions and they have come up quite a lot. Dun, dun, dun. Okay. Okay, so now, do people have any more questions on the content? We'll come back to the content after we do some exam techniques. Yeah. Okay. So exam techniques, revision. Revision is key to a good exam result. Okay. Sorry, I'm just looking at a question. Free science lessons. So do you have any good revision chemistry episodes? Have any of you guys heard Math and Physics Tutor? They have lots of questions, so past paper questions, and they're arranged in topics. Sorry, let me just look through the question. So how oh. Sorry, I just stopped sharing my screen for a second. So revision is the key to good exam results. So the way I used to approach revision, well, I still approach revision here at uni, is that I start by making notes. And hopefully throughout the year, you've been taking good notes in class, that's key. And the way I do it is I tend to just rewrite my notes, and that gets like the information into my head. Sometimes I type it up, sometimes I write it out a few times. So I just get everything that I need to know. I understand all the content, that helps me to learn the content. I usually reread these notes, and it just like keeps putting it back into your head. You keep like learning it, and it just becomes second nature. What I'd really recommend is using the textbooks. Textbooks have all the information you need to know for your exams. They're usually pretty in depth. So the textbook is your key resource, in my opinion, when it comes to, say, content. I personally prefer to use the textbooks than, say, use like CGP revision guides or things like that. Do you make the notes small, or do you write everything word by word? Oh, definitely small, yes. So say if you're, definitely like summarize it and keep getting lower and lower. So once you understand the content well, the way I did my GCSE sciences is I had like a project book, and everything was like, it contained all the different information that I needed. So I read through like the textbooks and the revision guides, and then I made my own summaries in my little book for all the different topics that came up in chemistry. And this helped me to understand this content well. So then once I understood the content and I had all these notes that I'd written out, I made flashcards with the most important facts. So say if we were talking about mixtures, I'd say compound, not chemically bonded, mixtures, compounds, chemically bonded, mixtures, not chemically bonded. And then hopefully like you'd remember that you have to separate chemically bonded stuff with chemical reactions. Or you can, so summarize it and just choose like the most important ones. Do I recommend CGP revision guide for revision? CGP guide are pretty entertaining, so it depends on your learning style. I like using mostly the textbook. The textbooks that were the official ones for the exam board. So and this allows you to build your confidence. So after you've done your revision, or even during your revision, so I think even the best thing would be to do, like, you cover the topics that are in your first paper and then start practicing that first paper straight away. But practice papers are the best thing to do well in exams, in my opinion. So do as many past papers as you can. I know you guys are on your new syllabus. However, the questions from the old one are also suitable, and they're really good practice. They're really good content. Great to like get used to answering questions. But and when you do past papers, it's super important to check your answers. Always check your answers. Always look through your through the answers, mark your answers against the mark scheme, because the mark scheme has what the examiner wants, okay? So the examiner, they don't have much time to read through your answers. They are just looking through it quickly, and some words, they just stand out. So say, we'll see in a sec, in the exam marking scheme, they usually put these important words in bold. And if you say this word, it's like a mark sorted, okay? So past papers, once you understand the content, is the best way to revise, or even just practicing like questions that have been found, like you could have bought, say, a worksheet book. But yeah, practicing. How long do I usually take to make notes? Because I take really long writing notes and absorbing knowledge. See, I take quite a while, I think, myself. I don't know, maybe compared to my friends, but I've done all my revision for my mocks in year 11. So if you do take notes slowly, then do notes like revision notes throughout the year. Maybe come Christmas, spend like a couple of days writing out notes that you're going to use when you come to your GCSEs. So it's not all like you have to do it at once. And then on top of your own notes, make the flashcards. But even if you just start practicing past papers, but you've got your notes there, answer the past paper questions using your notes. Do it as an open book exam. Don't just do it without your notes, because that's not so important. Yeah, so using diagrams is great, as someone suggested, making tables, summing things. Personally, I used to love using colours. I had loads of colourful pens. I always made all my work really colourful, and that just made it really fun. If we're studying, so revising at the end of lockdown, what grade do you think we are capable from getting? Still working at, I don't really understand Kiki's question, sorry. How does doing open book help? Well, it helps because that's just, you're doing both content and mark past papers. So it allows you to familiarize yourself with the content and also the past papers, so the questions. Are there any YouTube channels that are best for chemistry? Honestly, I could not tell you. I haven't done like chemistry in a long time now, like chemistry GCSE. I didn't use YouTube videos when I was revising though. Sorry, we'll come to what's fixed composition after we've gone over these stuff. So how do you become better at answering questions? Yeah, that is literally just past paper practice. So there's lots of resources out there that are great help. So just find all these past papers, and yes. So when making notes from a textbook, how do you identify what's necessary to write down and what is not relevant? Great question. Well, it might be if you're struggling with figuring out what's relevant, it might be better to look through some past papers before you start making notes then and see what they told us to search for. It's sort of your own judgment. A lot of the stuff is not that important, like the big paragraphs, but knowing equations, say like knowing the group 1 equations with water, that's really important. I guess you're going to have to judge that yourself. So yeah, let's talk about revision timetable. Revision timetable is super important. If you don't have a timetable, it's so easy to go off track. Still, I'm much older than you guys, and I still find it tricky to sometimes focus and like know exactly what to do when. But so revision timetable, the way I did it is once the exams timetable comes out, I don't really know when that is for you guys, I sort of plan my time to allow more time. Well, I started firstly on the test that came first. So say like paper 1 chemistry was obviously before paper 2, paper 3, or like it was before my English exam. I focused more on my time at the start on the chemistry, and then like plan to do the English a bit later. But having a revision timetable, I'd say what's really important, say with, what was it? Sorry, where's the question about procrastinating and everything? About preventing yourself from procrastinating, say giving yourself breaks. Making sure you have some breaks scheduled, maybe you have something nice planned after 6 p.m. Say if you try to study, or some of my friends, they used to say that, I'm sure you're going to get study leave, or some of you guys hopefully, but they used to study, say like a school day. So they'd wake up at 8 again, they start work from 9 till 12, they'd have their lunch at 12 to 1, and then they'd work from 1 till 4, like a school timetable. And then at the end after that, they just have a rest. So it is hard to keep focus, and also the other thing, especially with your GCSEs, you have such a variety of subjects. If you find like focusing on one thing for too long a bit difficult, put in like say 3 different subjects. Do 2 hours of maths, 2 hours of chemistry, 2 hours of physics, instead of doing a whole day of one specific topic, because that might keep your brain more. But it's how to get better at time management. That's just that's down to you. So you just need to try, say, find maybe what motivates you. What helped you follow your entries? How long do you revise each day? Oh, how long do I revise each day? I revise for a very long time usually. I'd usually revise, say, like, I'm not sure, probably from like 9 AM till about 6 PM, but with like a couple of breaks and obviously your lunchtime. But it just depends on the person. I quite like to study for a while. And I feel, because especially when you are in your GCSEs, you have so many different subjects that you're taking GCSEs in, that there is a lot of work that you can be doing. But the most important thing is to study, but also take breaks. So instead of having to procrastinate by taking breaks, schedule in like a 20-minute break after doing 2 hours of, say, science, and then do whatever you want to do. How did you revise enough during school days? During school days, well, at one point usually they start revising at school anyway, and then maybe do like 2 or 3 hours when you get home from school, or less. It's all down to the person. Whatever works for me doesn't necessarily work for everyone. I'd say having a variety in what you're studying. Yeah, so spend 1 minute per mark is a really good tip. Is there any way to remember things better, to remember most of the content? You're a quick learner. I think that flashcards are the best way to remember things personally, but everyone is different in that case as well. Do you have any tips for forgetting content? Then you should just like, so maybe spend half an hour going over something that you did not to, so like do it every single day, keep going over it until it starts getting your head, or put up makeup, make pretty posters, get some nice pens, get maybe some colored paper and make posters and stick them up around your room, so you're constantly able to see stuff that you're meant to remember. And that's also a great way to do it, through posters. Do you have any tips for getting motivated to study? Think about your long summer vacation, after summer holiday, after your year 11 exams, and how you're not going to have to do anything. You're going to be done with revision. Think about how your GCSEs are going to get you to where you want to be in life. Can I get a 9 in all science if I start now? That is not something I can answer. So that is down to the person completely. If you work hard, you all, I'm sure, will do great. But without revision, it's much, much harder. Well, revision is key. And I'd say looking over and trying to understand all the content. But it's not, you don't need to stress about it. Like, even just attending this revision course is great for you all. Reading mark schemes is very important. What subject did I find the hardest back in GCSE? Probably English. I have never been a big fan of English. How much did you revise? Dun, dun, dun. Okay. So I'm just trying to look at the questions. There's so many coming through. What did I get in English? I don't think that's very relevant to this one. Which option did I pick? I took physics, chemistry, and maths. So then, how to answer paragraph questions. Mark scheme for English is quite complex, yep. Do you have any tips answering what, explain, how, evaluate questions? In science? Yes. What? So with those ones, I'd say the key thing is to find them and then look through the mark scheme. Because the mark scheme, it tells you what they want. So commonly, especially like, you know, the science questions that are a bit opinion based, or just need to recall, like, it's sort of more opinions as opposed to actually chemical content. The mark scheme, it has all the answers that they could possibly want you to say. So I say, if you answer as many past papers as you can, you'll see so many more answers. You'll be way more familiar with everything that they're looking for. Okay. So yeah, exam techniques, manage your mindset. Always, everyone needs to try keep calm. GCSEs are scary, But if you start worrying too much, that's just going to prevent you from doing your best. So if you guys are revised, if you guys have put in the time and the effort, you will do as well as you want. I'm sure you will. Okay. Know your exam paper. Yeah, so when you sit the exam, always double read the questions. I still make silly mistakes just because I haven't fully understood or read the question, but those are the worst mistakes to make. So read it, don't rush yourself, take your time to understand the question and be fully aware of what they're looking for, and then answer the question. Okay, think like an examiner, this is key. Make your answers clear and concise. Really helpful with this is to look through past papers, because the past paper mark schemes, because these mark schemes, they have their words in bolds. So this is the word that the examiner wants to see, and this is the word he's looking or she's looking for. Okay. Answering questions, make sure you answer the question that they are asking. Don't go answering something that they're not looking for because you're unsure, because they want you to answer this exact question. But like someone said, aim for a minute per mark. So if it's a 6-mark question, aim for 6 minutes. And keep track of the time. It's really important to keep track of the time and organize your time well. Dun, dun, dun. Okay. So lastly, one thing that also worked well for me is working with friends. If you don't get too distracted when you see your friends, but with me and my friend in GCSE, we found out that she was really good at English, I was very good at maths. So we'd sit together and I'd help her with her maths. We do past papers together, discussing them. She'd get questions, I'd talk her through them. And then she'd do the same with me in English. Like we'd cover lots of different topics. She'd talk through different topics with me. And in the end, we both did great in our GCSEs, thanks to each other's help, as it's really good to work together. That's a really good life skill to have. Okay, so now let's do some past paper questions. So I think this was a 6-mark question. So in the periodic table, the transition elements and group 1 elements are metals. Some of the properties of the 2 transition elements and group 1 elements are shown in the table below. So this is this question that people have, like someone mentioned. So it's really common for you to get asked for the difference between group 1 metals and transition elements. So now, where is the question? Oh, that was a question. Oh, sorry. I think the question got mixed up. I think what the question is going to ask is compare the 2 together. Okay, what are the differences between transition elements and group 1 elements? And this is a 6-mark question. So the mark scheme for a 6-mark question. So firstly, you see the different levels, right? So level 1, level 2, level 3. Level 1 means that they have really basic knowledge. And then, yeah, so you might fail to make comparisons between the points raised. Whilst level 3 is detailed, broad knowledge and understanding of the key scientific areas. So in level 3, you've included everything that you've learned, all those facts that we've done in the past lessons that we did the other day, you've included all of them in your answer. So look at what they're looking for. So physical, we learned these properties, and we know these properties of group 1. So you need to compare them. So say transition elements, they have high melting points, while group 1 metals, they have low melting points. Transition elements, they have high densities, while group 1 metals, they have low densities. You can even say group 1 float on water, transition metals, they sink. And then, yeah, strong and hard and soft. So these are literally the properties we have seen, but you need to be able to make the comparison. You need to say what the transition element properties are and what the group 1 properties are. Okay, you can't just state the transition elements or the group 1 on its own. And then we've got physical properties, and then we've got our chemical properties. And so we've compared those 2 together. So yeah, these are your different things for this one. And one's key for this, ions with different charges and the coloured compound. So that's what they're looking for. So this would be a paragraph question. Okay, so if we go back to this part, this table, it's also hinting at these chemical properties, right? From this table, you can see that transition elements have far higher melting points than group 1 elements. So you can draw this conclusion from this table. You don't have to have memorized this in in the exam, but it's better to just know these properties anyway. And also from these oxides, we can see, look how many different oxides they form. And these different oxides, they're going to have different ions. And just in the same way, the iron, they've also formed different ions. So sometimes in questions, they give you this information. And it's really important to use this information, especially if, say, you're thinking, oh, I can't remember this property. Like, what is the difference in their melting points? You just look at the table and it's provided you with a lot of information. You can bullet point the answer. Yep, you can bullet point the answer. That's fine. Sometimes it even makes it better for the examiner when you bullet point it, because they can just see exactly what you've gone through. But like here, the mark scheme's been great to tell us what they want to see. From here, we understand exactly what they're looking for, exactly which points they're looking for. And when you hit all these marks, you get your 6 out of 6. Okay. So here, this is much more of a short question. So describe how this technique works by referring to process A and B. So all we need to say is, here it is. Would I recommend bullet pointing the answer or writing a full paragraph? Whatever you prefer. See, bullet points, they usually tend to be more concise, they're more clear for the examiner. So I think bullet points is great, but okay, whole comparison given which demonstrates. So you can say the bullet points, they would be transition elements have high melting points while group 1 have low melting points. The next bullet point would be transition elements have high densities while group 1 have low densities. Yep. So I guess it's all to make sense to bullet point it, but you don't have to. You can just write it out. Dun, dun, dun. I don't think we're going to have time for the third Kahoot today. Sorry. So, okay, where was I on? So this is, I'm trying to show you guys, I want to show you guys the use of the mark scheme and why it's so helpful to do past paper. So here, right, question about group 7 elements. Chlorine is more reactive than iodine. Name the products when formed when chlorine solution reacts with potassium iodide. So this, you need to think your displacement reaction. Does people have any idea for that answer? Is it evaporation? Or yes, Ava was evaporation. Brilliant. Yeah, brilliant. So it will be potassium chloride is the product formed. Why is it formed? Because chlorine is more reactive than iodine. Yeah. Well done to everyone answering it. So now this is a 3-mark question and we need to explain why chlorine is more reactive than iodine. Do people want to jot down 3 bullet points to say for the 3 marks in the chat? If people want to put any answers in the chat. And then we'll talk through it. What would be your... Okay, so Michelle, great attempt, but that's just 1 mark. So that would say get you to 1 mark. What would be your 3 points for the 3 marks? Okay, so explain why chlorine is more reactive than iodine. Sorry, trying to look through the answers. Next one. Yeah, brilliant, Malik. Some great answers here, okay? So now, well done for everyone's attempts. We'll look, so why is chlorine more reactive than iodine? Let's look through the answers. So chlorine's outer electron, so shell, is close to the nucleus, okay? So this is your first point. Once again, atomic size is also fine. You can say chlorine's atomic size is smaller than iodine's, so therefore the shell is closer to the nucleus, okay? Then the chlorine nucleus has a greater attraction, brilliant, some of you guys said that, to the outer shells. So exactly, so how do group 7 want to react? They want to gain an electron, and that's why this greater attraction between the outer shell and the nucleus is really important, and that's why chlorine gains an electron more easily. So what the mark scheme tells you is exactly what the examiner wants, okay? So now if you say in a year or 2 time, you come up, have the question like, why is chlorine more reactive than iodine? You know, first point is chlorine's outer shells are closer to the nucleus. The second point is about the attraction between the outer electron and the shell. And the last one is because chlorine wants to gain an electron to react, and it gains this electron more easily. So that's why mark schemes are the best, one of the best resources. Yeah, brilliant. Allow chlorine has less shielding, so you can use the shielding effect as well. That's to do with the attraction between the nucleus and your outer electron. So yeah, and it also tells you what else is allowed. So then you understand which content is really important, which you need to memorize, and what's not so important. Okay. Do any people have any last burning questions before we finish our last lesson? As we've run out of time now. How do you calm yourself or work under pressure? Just remind yourself that you've tried your best, and trying your best is all. That's all you should do. Trying your best is most important. Okay. And some of these questions were from Physics and Maths Tutor. I think it's a great resource. So yeah, don't think there's any more. I'm glad you guys, some of you have found it helpful. Yep. So the mark schemes are all online, so they are wherever you find the past paper questions. And yeah, and they always also come with all worksheets. So like on Maths and Physics Tutor, they also have the worksheets with their answers. But yeah, okay, we'll finish up here then. Thank you all for attending it. It's been a great week and I hope you've enjoyed it. Hopefully see you again. Bye.